Imagine you're a detective, but your crime scene? It's the entire universe. And the events you're investigating, they happened billions of years ago. Well, that's pretty much exactly what astronomers are up to right now. So let's dive into this cosmic cold case. And this quote really gets to the heart of it. You know how paleontologists dig up fossilized bones to figure out what dinosaurs were like? Well, astronomers are now doing the same thing, but they're sifting through the fossilized remains of giant stars, which are black holes and neutron stars, to piece together their incredible life stories. You could almost call it cosmic paleontology. Right, that is the multi-billion-dollar question, isn't it? I mean, these things are often totally invisible, they're unimaginably far away, and sometimes they're smaller than a city. So, where do you even begin to look? Well, it turns out the answer isn't to look, but to listen. We have this revolutionary new tool that lets us actually hear the echoes of the most violent events the universe has to offer. This amazing tool relies on something called gravitational waves. Just try to picture ripples spreading out, but not in water, in the actual fabric of space-time itself. The wild part is, Albert Einstein predicted they existed way, way back in 1915. It just took us about a century to build instruments sensitive enough to finally detect them. So here's how it all goes down. First, you get two massive objects, like a couple of black holes, caught in this cosmic dance, spiraling closer and closer. Then, their collision is so unbelievably violent, it sends out these powerful waves. And finally, these incredibly sensitive detectors back here on Earth, we call them LIGO, Virgo, and CAGRA, can hear those faint ripples as they wash over our planet. So, has this new tool been a game changer? Oh, you have no idea. Astronomers just dropped a treasure trove of new data, and it's giving us our clearest look yet inside this stellar graveyard. And get this, in just the first 9 months of the latest observing run, which only kicked off in May 2023, the rate of discovery just went into absolute overdrive. They detected 128 new cosmic mergers. 128, that's 128 more cosmic fossils to add to our collection. And every single one tells us a unique story about the most extreme objects in the universe. And buried in all that data was something incredibly rare, a black hole swallowing a neutron star. Now, to give you some perspective, before this latest run, humanity had only ever confirmed one of these events in all of history. This new data found a second one. In just a few months, we instantly doubled our entire catalog of these mixed mergers. But it's not just about the numbers. They also heard the merger of the heaviest pair of black holes we've ever found in this gravitational wave range. We're literally pushing the boundaries of what we even thought was out there. Okay, so we're finding more stuff, and we're finding bigger stuff. But so what? Why does any of this actually matter? What secrets are these echoes really telling us? Well, it matters for three huge reasons. First, these cosmic fossils are helping us rewrite the life story of massive stars. Second, they're giving us a brand new ruler to measure how fast the universe is expanding. And third, they create a cosmic laboratory where we can test Einstein's theory of gravity under the most extreme conditions imaginable. Let's dig into that second point, because it's a huge deal. The rate the universe is expanding is called the Hubble constant, and it's one of the biggest puzzles in astronomy right now. Different methods keep giving us different answers. But what's so amazing is that gravitational waves give us a really direct way to measure the distance to these mergers. So every single new detection helps us zero in on that true value. And what about Einstein? Well, one of the signals they just found was the loudest one ever recorded, which gave scientists their most precise test yet of his theory of general relativity. And the result? Over a century after he came up with it, Einstein's theory has passed every single test we've thrown at it. The man is still undefeated. But you know how science works. It's never really finished. Every new discovery just brings new questions, and this one has revealed a really fascinating new puzzle for us to solve. So here's the mystery. When a black hole rips a neutron star apart, our theories predict it should produce a massive flash of light, right along with the gravitational waves. But for those two mixed mergers they just detected, nothing, zero. Just the gravitational waves. The light was missing, which is deeply puzzling. Now, the solution might actually be just around the corner. We're building bigger and better telescopes, like the Vera Rubin Observatory that's coming online soon. It's going to scan the entire sky every few nights. And the hope is, with these powerful new eyes, we'll finally be able to catch these mergers in the act and see that flash we're so sure should be there. Which really just leaves us with this final thought. We have only just begun to listen to the cosmos. And if we've learned this much in just a few short years, doubling our knowledge of some events in a matter of months, what other incredible secrets is the stellar graveyard still waiting to tell us?